All right, so the title, evaluating trig functions at any angle, almost any. And when we're talking about evaluating, we're talking about, for the most part, analytically. Now, we're not talking about, evaluating them with a calculator. You can always just type it in. But some of these problems you cannot use with a you cannot use a calculator for. So it's important to learn this method. So here's what I want you to do. First thing, with your calculator, again, make sure you're in degree mode. Okay? So I want you to do sine of 150 degrees, cosine of 150 degrees, and tangent of 150 degrees. Okay, on your calculator. All right, get those answers. All right, what do you get for sine of 150?
0.5.
0.5. So we know as a fraction that's 1/2. I'm just putting that so maybe it rings a bell on something. What did you get for cosine of 150? Negative 0.866. Well, and then whatever, it doesn't repeat, it doesn't terminate. This is negative square root of 3 over 2. 0.866 is square root of 3 over 2. And then your last answer, tangent of 150, you got what? Negative 0.577. Well, if you look, we know tangent is sine over cosine. It should be 1 over negative square root of 3. So that is negative 1 over square root of 3. These are synonymous. I mean, these are the same value. Now, here's what, and these are decimals that keep going. So I want you to do sine 30, cosine 30, and tangent 30 on your calculator. Okay. And you should notice something. When you do sine 30, cosine 30, tangent 30, what do you notice?
Without the negative.
So it's the same values except they're all what? Positive. Okay. So first question. Well, I have a couple of questions. So we got the same answers, but no negatives. 1/2 square root of 3 over 2, 1 over square root of 3. You got the decimals for those. I like writing it like this because it's exact. I don't have to worry about how many decimals do I put. Okay. First question. If we're doing right triangle trig, how could we have a 150-degree angle? If we're doing SOHCAHTOA, sine, cosine, tangent, how could we have 150 degrees? Would that be tough to have in a right triangle? Yeah, well, that's one issue. What's the other issue you see with these answers on the left? There's a negative. So how can you have 150 degrees and how can you have a negative? Well, the first thing we have to do is we have to expand our mind a little bit and just understand that sine itself is a function. It is a function, and if you were to graph the sine function, you would see that it does this forever. So that means that you can plug in angles here or x's, right? Those are your inputs, and your outputs are ratios, but they're also y's. And you can see some of your outputs are positive, and some of your outputs are negative, and you can even get an output of 0. There is a way to get an output of 0. So if we think of sine more as a wave, then we understand that these answers are possible. So just to show you that you can get a 0, do sine of 180 real quick and see what you get. It should give you 0 if you're in degree 1. Okay, and you get 0. You're like, well, with a triangle, that doesn't make sense, but with a wave, it makes sense because And that could be the same as pi, instead of, because you can't plug in degrees. But you can see, I can tell you right here, this is pi. And pi is the same as 180, so sine of pi is 0. So we think of sine more as a wave, rather than always just thinking of it as right triangle trig, then we can see that these are possible, okay? So what I want to show you is how can we do similar to what we've been doing, was using right triangles and get these answers and know which ones are positive, which ones are negative, and try to tie it in together. We'll come to the wave stuff later, but I just want you to understand that if you were to graph the sine function, you would get this picture, okay? So let's look and see how this happens. So what we're going to do now is we're going to get these answers by hand without a calculator. How do we get these by hand without a calculator? Okay, I'm going to erase. Is that okay? All right, so, and I'm just doing sine, cosine, tangent, because if I want cosecant, secant, cotangent, we just do what? Flip. All right, so this is save time, just to make sure. So we want to do, so we're going to say example 1. Find sine theta, cosine theta, and tangent theta for, in part A, we're going to do theta is 150 degrees, and then part B, we're going to do theta is 225 degrees. And I think if I do these two problems and we go through these, and we can maybe have an understanding of how we're going to do it. All right, this is one of these problems have a recipe to them. So I'm going to go ahead and make the recipe here as we work the problem. So I'll put the recipe for this. So this is, the recipe is for finding sine, cosine, tangent of any angle. When we're saying any angle, you'll see there's a theme to these angles. There's something special about these angles. Okay? So step 1, draw the angle in standard position. So we need to create positive and negative signs, because we know some of our answers are going to be negative. We're going to do the 150 again. So we're going to put the angle on the coordinate plane. Okay? So as I do the step here, we'll work it out over here. So I'm going to take that angle 150, draw it in standard position. All right, there's that 150 degrees. Somewhere in the second quadrant, okay? So I draw that. All right. But if we're going to do sine, cosine, tangent, we need a what? What do you need to look at in order to know to do sine or cosine or tangent? A triangle. We need a triangle. Why not we don't have a triangle? So we're going to make a triangle. We're going to make a right triangle. Step 2. These steps are literal. Draw a perpendicular to the x-axis. X-axis. Always to the x. So you go from the tip of the angle to the x. Okay? So I'm going to go from here, and I usually just do a dash line. I'm going to draw a vertical line down to the x-axis, which now gives me a right angle, and hopefully the nice right triangle has popped up. You know, it's like, look at this picture and you'll see a car. I looked at it, I was getting, you know, those kind of where it's got all this weird stuff and you're supposed to find a car in it. This is much easier. Find the right triangle. Oh, I see it. Good. This is the one you can do. All right. So now, well, if I draw that triangle there, do you know anything about the triangle? What do you know? It is a 30-69. Okay? So the next step we're going to do is we're going to find this angle here. Because see, remember, don't forget, we're trying to find sine of 150 degrees, cosine of 150 degrees, and tangent. And the trick is, there's no 150 degree angle in our triangle. It's outside of our triangle, And we're gonna use the angle that's right here to do that. We're gonna do all our SOHCAHTOA from here. And this angle right here has a special name, okay? So step 3 is gonna be find the reference angle. Find the reference angle, and the symbol for that is theta prime. And it is located between the terminal side of theta and the x-axis. So it's always between the angle itself and the x-axis. Remember that. Okay, again, draw your perpendicular to the x, and your angle is always, because as these angles go in different quadrants, you gotta always know where to find the reference angle. All right? So you find the reference angle, so what is it? 30. Now if you get 30, 60, or 45, you now know the sides of the triangle. If you don't get 30, 60, or 45, forget about working the problem. So that's why I put evaluate trig functions at any angle, almost any. Because they have to give us a 30, 60, or 45 for us to continue. Then there's a way to not know the angle and work it, and I'll show you from there. But if they give us an angle, we've got to hope that we get a 30, 60, or 45. So now that we have a 30, now I'm going to label the sides of the triangle. Now, so now that you know the reference angle, you can label the sides of the triangle. However, so let's go ahead and put them, and then we'll show you where we're contradicting ourselves a little bit and where we're going to fix it, okay? So what side is typically across from 30 on a 30, 60, 90? This is where you got to memorize those triangles and know. 1. What side is adjacent? Square root of 3. What's the hypotenuse? 2. Now, remember our answers, though, that we got, 2 of them were what? Negative. Okay. So, let me ask you a question. Look right here at this point. See the tip of the angle? What point is that right there? You have the information to know. What point is this right here, this location? Now, I'm asking for an x value and a y value. So listen to my question. What is this coordinate? I would like to know the x and I would like to know the y. It is on the board. If you can play Battleship, you can answer this question. Almost. You're missing something. Negative square root of 3, 1. Because we are in the second quadrant, and what do you know about x in the second quadrant? Negative. So your sides of your triangle must jive with the point. They can't contradict themselves. So now when we label our triangle, if an x needs to be negative, we got to make it negative. If a y needs to be negative, we got to make it negative. The hypotenuse is always positive. So what we're going to do is we're going to label the sides of the triangle, put the correct positive or negative sign on the XY legs. If you miss a problem, this is 90% is where I tell you to go. Go back. If you put the, I'll look at the students' work, every triangle they did, all the sides are always positive. You're gonna be missing a lot of problems. Unless it's just asking, if it asks for just a, sine in this quadrant, you're okay. So, in order to fix this, I'm gonna make sure that that is negative square root of 3. And then that's it. Now, do SOHCAHTOA from the reference angle. So let me make sure that we're clear. We are not finding sine cosine tangent of 30. We're finding sine cosine tangent of 150, but from that 30 degrees. So from the reference angle. So we're going to go here and do your SOHCAHTOA. Because if it was 30, all my answers would be positive. Same thing, 30 degrees is in the first quadrant and everything's positive. So I go from here and I answer the question. So let's see. 30, what's sine? 1/2, opposite over hypotenuse, and that's why that answer was positive. And then you did your cosine. What's cosine? Adjacent over hypotenuse, negative square root of 2, and that's why it's negative. And that's why we get a negative, because there. Do tangent of 150. So we'll go from here, opposite over adjacent, 1 over negative square root of 3. I would say negative 1 over square root of 3, and that's why that answer is negative. Okay? So we'll save that recipe there. I'll erase this in a second. You're going to do the whole thing again for this angle, and then you're going to go and do this for this angle. Okay? You're going to have to figure out how to do that one. Probably put it in what? Degrees. Okay. Go ahead and see how you do. Okay? See if you can do part B. Let's take a couple of minutes, do part B, and you're going to find sine cosine tangent of 225, and there's your recipe. And that recipe is located, anybody want to know what book you find it in? Armand's book for Jedi Master Math that I'll be writing, okay? They'll come out, we'll sell it on Amazon, hopefully. And it's got all my little tricks and shortcuts. And then I retire and I go golf every day and surf and whatever. Yeah, on the beach. I gotta grab 2 drinks out of here. So. So we're just doing part B right now. Make sure that you, if you can do that one, follow the steps. I promise you on part B, the reference angle is the one from a special triangle. So what quadrant is 225 in? What axis do you always draw your perpendicular to? Where's your reference angle always located?
Between the terminal side
And the x-axis. It's that angle closest to the x. And it has to be in the triangle, otherwise you can't label the triangle. So, number one, if you don't have your special triangles memorized, it's gonna slow you down. If you don't, if you're slow at converting from radians to degrees, it's gonna slow you down. So the quicker you master the simpler things, the easier this gets. The farther you're behind on the simpler things, the more complicated this gets. So, you'll go through it. Step one, draw the angle. Step two, draw a perpendicular to the x. Did that. Reference angle is here. So if from positive x to here is 225, what's the reference angle have to be? 45, because it's 45 past 180. Now, what are normally the sides of a 45, 45, 90? The legs should be what? Ones. And the hypotenuse should be what? So, and let me just stress, hypotenuse is always positive. Okay? So, what do the ones have to be? They both have to be negative because remember they correspond to this point, third quadrant, x and y are both negative. So if it helps you to label that point and then label the sides, that's fine. And then from here it's just SOHCAHTOA. Sine 225, cosine 225, and tangent 225. So let's see. What do you get for sine of 225? You go from here, and then this is your opposite, this is your adjacent, that's your hypotenuse. So what are your answers? Cosine 225. Tangent of 225. 1. Negative 1 over negative 1 is 1. Right? You put negative 1 over negative 1, you get 1. You can flip to get the other ones. Okay? Now if it tells you to rationalize, and you got to multiply by square root of 2 over square root of 2, that's a pain. Okay? All right. You've done 2. Let's do a third one. Now, a hint. How do you, first of all, how are you supposed to, what do you think we should put this in? Degrees, I would. How do you put radians to degrees? You can either multiply by 180 over pi, or you can remember what degree measure that is and put that in. Or if not, you just have to multiply by 180 over pi. Either way, you should get the degree. Okay? And then go from there. Same recipe. Recipe hasn't changed. Just because your angle is negative doesn't mean your reference angle is going to be negative. Your reference angle it should always be positive. This is just telling you how to draw your big angle. Your reference angle should be still between the terminal side and the x-axis. This is probably going to put it in a certain quadrant. Okay. So the negative. Remember, if it's negative, you go clockwise from the positive x. Okay. Okay, so I'm going to show you what I would have done, and I'll catch up to you and we'll go from there. So I would have said -5 times 60, because I have it memorized that pi over 3 is 60. If you did this, you still would have got 60, okay? So that's -300 degrees, which puts our angle in which quadrant? 1. Once I know that that happens, I know x and y are both positive in the first quadrant. Drop my perpendicular. Now, let's think. I'm how short of one revolution? 60. So you're going to have some understanding of, well, how are you going to know to find that? Well, I can't go through every scenario, but use the axes and use the fact that one revolution is 60 degrees. I mean, 360 degrees. So I know that I'm 60 degrees short, and I just put a positive 60 in there because the negative just showed me the direction. Okay? All right? Everybody with the understanding of why I did that. Okay. Negative just means draw it this way. Okay. And that's it. What's opposite of 60? Yeah, label on my sides adjacent. One hypotenuse is 2 places that students miss it. They mess up on the reference angle, thus messing up on the sides, or they don't put the correct positive or negative sign. In the first quadrant, what do you notice about everything? Everything should be what in the first quadrant? Positive. All positive in the first. Okay, and then that's it. And remember, we're finding sine, cosine, tangent of -5 pi over 3, not of 60. But notice, is -5 pi over 3 and 60 the same angle? In this case, it is. Whether I go this way or I go this way, I'm going to get the same answer. Yeah, coterminal, that's exactly right. So what are our answers? What did you get for sine? Cosine. Tangent. Done. What point is this here? 1 squared of 3. Okay. All right, so far so good? All right. We're going to leave the recipe there. Now you use this recipe on just about every problem in this section, except sometimes you don't need the whole recipe to do it, okay? So I'm going to show you a different type of problem that we're going to get now, but we're going to still find sine, cosine, tangent. For the next one, we'll do all 6 trig ratios, just to remember. But I'm just trying to save time and just to get sine, cosine, tangent. Remember, if we want cosecant, secant, and cotangent, those are the reciprocal functions, and we just flip. Okay, so the next problem we'll do all 6. All right. So next type of problem. Example 2. We'll do 2 of these. Given the point on the terminal side of theta, evaluate the 6 trig functions of theta. All right. So part A, the point would be 4, -3. And part B, the point will be, negative 5, 12. All right. So what I'm telling you is think about when you draw that angle, I'm telling you what point it touches. So now we know the tip of the angle. Okay. But believe it or not, we can still follow the same steps, just pretty much the same, except we don't need one of the steps. Okay? So what I want you to picture is, can you guys picture what quadrant that point 4, negative 3 is in? What quadrant is that? Fourth. Okay. So here's what we're telling you. 1, 2, 3, 4. 1, 2, 3. There's the point 4, negative 3. And what I'm telling you is that the angle, it's there. That's your angle. So just think your angle's like this, okay? And your angle hits there. So now you've got your angle drawn. So I'm always going to draw my angle from the positive x-axis. All right, so now, what are my steps? Next step, first step I draw the angle. What's the next step? Perpendicular, all right? I always go to what axis? X, boom, there's that. All right, next step, find the reference angle. Well, where would the reference angle be located? I'm gonna point, you tell me yes or no.
No. Yes.
Now, here's the problem. I can't find the reference angle. Why not? You don't know it. What do you not know? You don't know the big angle. However, what is the reason for finding the reference angle? What do you use it for? To label the sides. You already know the sides. There you go. Go ahead, finish the problem. I skipped step 3, I don't need it. Now I'm at step 4. I'll do 1, 2, skip to 4, and then do 5. Everybody see how we know the sides? Because you know the point. So notice, this side is the x side, this side is the y side. Okay? How are you going to find the hypotenuse? Sure. There you go. If you finish this one early, yeah, we'll do all 6 on these two. If you finish this one early, move on to the part B. I'm gonna catch up to you. We can move on because we're filming this. So, x side is what? 4. Y side is -3. Hypotenuse is what? 5. Hopefully you just memorized it. This is a 3, 4, 5 triangle. But if you did your Pythagorean theorem, in this case it's x squared plus y squared, and the symbol we use for hypotenuse is r. And I'll talk about that later while we do that. But you can plug everything in. 4 squared plus -3 squared is r squared. This adds up to 25. So square root, 5 is r, the hypotenuse is r. Okay. Well, then that's it. You do everything from here, remember? Okay, so let's see, sine of theta, we got what? Cosine theta. Tangent theta. Cosecant theta. Yeah, just put your negative in front, that's right. Don't do 5 over -3, kind of awkward. Secant theta. Cotangent theta. There you go. So we still put the negative in front, okay? There's that one. So, do you guys know what a Pythagorean triple is? A Pythagorean triple, notice what's interesting on this, is that there's no square roots. It's very rare when you have a right triangle that one of the sides doesn't have a square root on it. Usually one side is a square root, okay? So if all sides are integers, 3, 4, 5, then it's one that we memorize so that it's a lot quicker to label. So we know, all right, 3, 4, 5, and then any multiple of that. So a 6, 8, 10 would also be a Pythagorean triple. All right, that's one. This is a Pythagorean triple. 5, 12, does anybody know the hypotenuse? 13. 7, 24, 25. 8, 15, 17. I think. I'm pretty sure, yeah. All right, those are the 3 or 4 most common ones so maybe that will help you. So look, if I see a point that's 7 and 24, I'm happy. I know the hypotenuse, I don't need to do the work, okay? All right, answer part B real quick and then we'll move on, almost done. If you can do part B, I already gave it away now, most of the work is done. You actually could probably answer it, well, you better just do the work. I bet if you don't draw it out, you're gonna miss, it's better if you just draw it out. It could be 12, it could have been -12, 5. It doesn't matter, it's still 5, 12, 13. Doesn't matter which leg is which. As long as the legs are 5 and 12. See, we got it. All right, so this side right here, -5. This leg is 12. What's the hypotenuse? 13. And then let's just write our answer. So again, we're going from here to do our SOHCAHTOA. So what's sine of theta? Cosine theta. All right, and then tangent theta. 12 over -5, so -12 pips. Okay, now, so I'm going to erase that recipe. Let's take a sidebar for just a second and make sure that we see if this makes sense to us, see if this is right. And then we'll do one more type of problem and that's it. You should be good to work. And we'll probably continue into Thursday as to finish the workup. Okay, so let's see if you agree with this. So no matter where I draw the angle, let's say I draw it in the first quadrant. Let's use symbols now for our triangle. What would you call this side? We're going to use a symbol. Could use A. We can be a little bit more specific than A. Notice I'm drawing it in the coordinate plane. So that this side goes with this coordinate. Right? So this coordinate's an XY. So the horizontal side here is X. The vertical side is, remember I said that we use what R for hypotenuse. So with Pythagorean, and later on we'll look at why we use R. Yeah, think about radius of a circle, right? So Pythagorean theorem, we get x squared plus y squared is r squared. So r is always square root of what? X squared plus y squared. There's that. Now, that's all I want you to see. If I did SOHCAHTOA here, sine of theta would be what? Just using this triangle. Sine of theta is what? Y over r. Cosine theta is what? And tangent theta is what? My question is this. No matter what quadrant I draw the angle in, is sine always y over r, cosine always x over r, and tangent always y over x? Because is x always the adjacent? Yeah. Is y always the opposite? So it doesn't matter. No matter where you draw this triangle, these are always your ratios. Now notice, in quadrant 1, everything is positive. Let's just go to quadrant 2 real quick. So you're not going to change how you label it. All right, this is still an xy, except one of those coordinates is negative, right? So, but it doesn't change. This is still x, this is still y, this is still r, except x, I know its value is a negative. You still use x for it. So now if I wanted to find here in the second quadrant, sine of theta is still y over r. Cosine of theta is still x over r, but knowing that x will be a negative value, and tangent of theta is y over x. Now question, in the second quadrant, only one of those three is positive. Which one? Which one? No, only one ratio is positive, not one side. Two sides are positive, but only one ratio is positive. What's the only ratio that's positive? Sine. So in the second quadrant, sine of theta is greater than 0. Okay? But they're always, sine is always y over r, cosine is always x over r, tangent is always y over x. Now, without me drawing the angle, I want you to think about quadrant 3. Out of those three ratios, sine, cosine, tangent, only one is positive. Which one? Why is that? Very good. Well, let's see. That's why I always like to think about, use common sense. First quadrant, everything's positive. Second quadrant, sine's positive. Third quadrant, tangent's positive. Fourth quadrant, it's got to be cosine. And it is, because it's x, and think x is positive in the fourth quadrant. It's only cosine is greater than 0. So this is a good little, what we do, a way to simplify. Now, sorry, before I go to that statement. If cosine is positive, who else has to be positive? Somebody else. We haven't talked about them much today. Secant, the flip. If tangent is positive, who else is positive right here? Cotangent. If sine's positive, who else? And everything's positive in quadrant 1. Now, that right there, you start looking at that and stuff starts flying around at you, right? Like three-dimensional, messes you up, it looks crazy. Here's what we do. All we do is this. And the saying is, all students take calculus. And then you can remember it. All students take calculus. Boom. Okay? So this is a little chart to tell you which one's positive where. And now that will aid us in our last problem that we're going to work. Okay? Don't get too excited about the song I just taught you, the little saying. Don't go around all day chanting it. People will think you're crazy. The last problem. Example 3. Find, I have to just work it one at a time, so let's just do this. Given sine of theta is -2/5 and tangent of theta is positive. Find cosine theta and tangent theta. So notice, in order to work this problem, I'm still going to follow the recipe, right? The recipe is, first step, draw the angle. But I can't just draw the angle without knowing where the angle is. But I've given you 2 clues. See? You see sine is negative, and you actually know y and r. Right? So think about that. And then I told you tangent is positive. So by process of elimination and using all students take calculus, see, this is telling you where sine is positive. Everything's positive, sine's positive. So if you don't have an S down here, this is where sine's negative, 3 and 4. So either it has to be quadrant 3 or quadrant 4. Well, by process of elimination, tangent is positive. Now you know which quadrant it is. Now you can draw your angle. Now you know 2 of the sides. Now you can do Pythagorean theorem, find the 3rd side. Then you can find cosine tangent doing SOHCAHTOA. Boom. You got it. If you can work this problem, and that's pretty good. I think we've pretty much hammered it. And then you can tell me if I've left anything off on Thursday. All right, so what are we thinking? Which quadrant? 3, okay? So quadrant 3 is right, because sine is negative and tangent is positive. So sine's negative here, tangent's positive is there. Draw my angle, draw my perpendicular. I know y is and r, so y is -2, r is 5. Now, if you don't get x right, it's going to be wrong. So I'm going to put my x here and know my x answer has to be what? Negative. If it's not negative, you're going to mess it up when you go to find cosine and tangent. So x squared plus -2 squared is 5 squared, and we will get a square root, you're right. X squared plus 4 is 25, so x squared has to be 21. So x is plus or minus the square root of 21. So you got to make sure you make it minus. Okay? Very good, good on the work there. See how I showed my work? So here we go. X is negative square root of 21. We got that. And now do all, so if this is your theta, do all of your SOHCAHTOA from here, from your reference angle. And you only need cosine and tangent. That's it. We already know sine. Okay. So what's cosine?
Negative square root of 21 over
5. And then what's tangent? Opposite over adjacent. 2 over square root of 21, so you just cancel your negatives. If it said rationalize, what would the answer be?
3 times square root of 21.
Very good. Multiply top and bottom by that. That concludes the lesson today. Hopefully that helps. Okay? That's it for today. This lesson is open and available in Course Compass, and good luck.